Another operation you'll do often is to take a binomial and square it. So what that means is that they want you to take k plus 8 and multiply it by k plus 8. So using FOIL, we would end up with k squared plus 8k plus 8k plus 64. We combine those middle terms and we get k squared plus 16k plus 64. Trying it with the second example, 3a minus 4b times 3a minus 4b. Following our FOIL pattern, we'll get 9a squared minus 12ab minus another 12ab plus 16b squared, because this negative times a negative is going to give us a positive b squared. And combining our center terms again, 9a squared minus 24ab plus 16b squared. So there's another pattern that happens with this kind of binomial. If you'll notice, when you're squaring binomials, your two middle terms always end up the same. 8k and 8k there, both positive. Over here, negative 12ab, negative 12ab. So that lets us take a shortcut that our first term, since we're always multiplying k times k, and our last term, 8 times 8, are going to be squared just like they were in the page before where we had plus and minus in our two binomials. So the first and last terms are squared, and then the middle term is twice the product of both terms, which sounds like one of those word problems that you have to untangle where it's twice the product of something. Okay? So let's look at this in some abstract examples. If they give us a plus b squared, which is like this first one, we had a k plus an 8 squared, it's always going to equal the first and the last term squared, so a squared and b squared, and they're going to be positive, and then twice the product of both of the terms. So the product of a and b is ab, and twice that is going to be 2. If we have the difference of two terms, we still see that the first and the last are the terms squared, and they're positive because a negative b times a negative b is going to be positive again. And the only thing that differs here, it's still twice the product of these, but the product of an a and a negative b is going to be a negative ab. So twice it would be a negative 2ab. So if we try numbers 93 and 94 using this shortcut, our first one, 93, looks like an example that looks like this. We've got a difference of two numbers. So I'm going to write my answer as r squared, leave some space, and a plus 25, because you'll notice that second term in both cases is positive. So 5 squared is 25. And then in the middle, I multiply r times negative 5. That gives me a negative 5r. And when I double it, it's a negative 10r. Doing this one, I square the first term and square the last term, so this becomes 1/4 w squared. Be careful, I see a lot of students just calling this 1w, but we're not taking 1/2 and adding 1/2, we're taking 1/2 and multiplying 1/2, which is going to come out 1/4. Leave some space. The 5, when you square it, is 25, positive again. And then, because this sign is positive, when we multiply these two together, our answer is going to be a positive. So 5 times 1/2 w is 5/2 w, and when you multiply that by 2, I'll do that over here on the side so you can see it. 1/2 w times 5 is going to give us 5/2 w, but remember we need to double it. So when you multiply it by 2, those 2's are going to cancel out, leaving you with just 5w. So 1/2 w times 5 times 2 all simplifies down to just a 5w.